in this spreadsheet, you will be able to play with some inputs for radiation, flame radiation, and try to estimate some outputs. So the inputs are air temperature, flame depth, emissivity of the combustion zone, flame temperature, flame length, emissivity of the flame zone, and flame angle. And the outputs are basically the radiant energy rate from the combustion zone and also the energy from the flame to the fuel ahead. And so there is a total outward energy rate from flames, and there is a total radiant energy rate loss in fire, which could be also important for calculation of the components of total heat release. So just for a small example, uh, we could try to see what kind of inputs we should have, and it's clear that there are some inputs that are difficult to have: emissivity of the combustion zone, emissivity of the flame zone. And for these, we generally rely on some estimates of emissivities of of fires with different intensities. So it's a low intensity fire will have something between zero point 0.1 and zero point 0.3 for values of the emissivity in the combustion zone, and between zero point 0.1 and zero point 0.2 on the flame zone, according to Telitsin, with a Russian scientist. And also we can have estimates that are observed by other researchers and are dependent on the different characteristics of the flames. For instance, for this one, if you have the flame depth of 5, you'll have an emissivity of 0.99. So very deep flames will have an emissivity very close to 1. If the depth of the flame is quite small, let's say 1 meter, then we would have, let's say, the emissivities would be much smaller, or the flame zone would be 0.55 instead of 96 if it was a 4-meter deep flame. So we can also use that as a good reference. For instance, we know that if we have a 4-meter depth in the flame, it's of course a fire with a high intensity, and the value should be somewhere between 0.7 and 1, which is consistent with the estimates that are provided by these researchers. So by using that, we can have an emissivity value. Let's talk about high intensity fires. Let's have 0.9 here, and the emissivity of the flame zone also 0.9. So we are talking about really high intensity fires. Flame depth of this sort, 3 meters, and then we can look at flame temperatures. Let's put 1000 K, and then the flame length of let's say 5 meters. So really intense fire, high flames, and a flame angle of 60 degrees. So this is kind of a good description of a high intensity fire. And so we have intermediate steps, energy fluxes from the various areas, and then you have this radiant energy rate from the combustion zone and from the flame to the fuel ahead. And that is important because we can also look at the radiant flux, radiating flux at a certain distances from the fire front, 5-10 meters to 50 meters. And we can see here that the radiating flux is decreasing very sharply with distance, and that's what you see exactly in the graph. And the importance of these values for safety is extremely significant because you know that above 4.7 kilowatts per square meter you have problems for people without protection. After 6.4 you have pain, after 8 seconds of skin exposure, and you have different consequences and different impacts of this radiant heat flux. And because of that, you can have safety distance for firefighters as a function of this heat flux. So it means that we should, as firefighters, the, the safety distance from fire is about 20 meters on this fire. So it's about where we have in 20 meters you have 4 kilowatts per square meter, which is let's say a value more or less related with this limit for danger for people without protection. And of course, if you have protection, you can go a little further, and you can see that from these kind of equations. Also, you can see the impact of flame temperature. If you have, let's say, flames that are more with higher temperature, 1200 K, then you can see that there is an effect there. But the major effect is on in flame length. So if flame length is 2 meters, then in this case, let's say the whole picture changes and the distance from fire is much lower, the safety distance from fire. So you can play a little bit with that and see what the consequences are.